Glad to be here. I'm presenting Epishine and how to make self-powered smart building solutions using indoor solar cells. My name is Jonas Engstrand. I'm a senior account executive here at Epishine, a Swedish company. And to just start off a bit, 37% of the global CO2 emissions are from buildings. And out of these 37%, a whopping 70% is from operational emissions, so lighting, HVAC, heating, and so on. And to actually cope with the 2030 goals and also the net zero for 2050, we really need to reduce these numbers a lot. And one way to do that is, of course, with Proptech, to actually lower the CO2 emissions is to measure. So what is the physical world actually? How does it look like? And for measuring, we need sensors and IoT devices in many places, like for thermostats, temperature, humidity. We need occupancy sensors to know how we actually use the buildings as well. And recent numbers shows that by 2025, we will have 150,000 new connected IoT devices per minute. And it's quite a vast number. Just imagine how many that is for a year. And to just play around with those numbers a bit, let's say all of these will be battery powered with 2 batteries each. That leads to 158 billion batteries a year. So imagine then when you need to replace all of these batteries after maybe 3 or 4 years, and all the maintenance costs that you have with that, and also all of these go into landfill as disposable batteries does today. So we at Epishine, we don't find this a sustainable solution, even though it actually measures for a good cause. So in our sense, the future of sustainable IoT needs to be self-powered. And from Epishine's side, that is with light. So you can actually power IoT devices using these indoor solar cells. And much like outdoor solar cells, whilst they actually convert sunlight into energy for buildings, we convert light from lamps and ambient lighting to power electronics instead, to eliminate the need for batteries and wires. And our cell is a printed organic solar cell. We make them in a roll-to-roll process, which makes them very cost-efficient and also sustainable in that sense as well. And because it's very thin, flexible, it's very easy to integrate into everyday products. So these are just examples where you have a remote controller, for example. You don't need to replace the batteries in that anymore if you choose to have an indoor solar cell. You have electronic shelf labels in retail where you need to replace the batteries in those also after a couple of years, or even throw it away. And also a concept here is an earbud casing can also be powered by light. So to go back to the sustainable building operations, we have some competitors, of course, the wired solutions and also battery powered ones. If you look at the wired solutions, they are very high in reliability, but yet they're expensive. It's very difficult to retrofit something as well because you need new wires, and how then do you do that? You need to open some walls and so on. It's very expensive and cost inefficient. Then you go to the battery powered ones, which are more and more common. And it's flexible when retrofitting, it's easy to install, and it's cheaper than the wired solutions. But it comes with a cost because you need to replace the batteries after a couple of years, and you need to do it 3 to 4 times over the lifetime. And then, of course, you also have the regulations coming in every year about disposable batteries and also lithium batteries in everyday products. So in our perspective, self-powered electronics is by far the best solution because you have the same flexibility as the battery-powered ones and a higher reliability as well. So you gain a better environmental and you get rid of the disposables of the batteries. So to take with you is that you can actually, from the building like facility management perspective, and also new builds and facility owners, you can actually lower the TCO of buying these devices. So actually, we have a couple of customer products with us at pod number 2. This is one of them from mClimate, who's also here today. So this is fully autonomous and self-powered by our indoor solar cell, and can operate and measure CO2, temperature, humidity, and lighting as well. So by that, you can lower the total cost of ownership. You get a cheaper installation. If you figure out that you actually need to move it around a bit, it's very easy because it works with a double-sided tape, so you can actually move it. So you don't need to use any screws or so. And also by using the indoor solar cell, you can reduce the power management CO2 by 85% compared to battery powered ones, and cut maintenance up to 100%. And our solar cell, it functions after 10 years as well. So you get a really, really good way of working with indoor air quality. And here are some examples of where you can actually use indoor solar cells. So for example, for smoke detector, to have a backup for the battery. So you can have temperature, humidity sensors, remote controllers, for example, for the your air conditioner, for example. Locks, you have door sensors for the alarm. All of these can be powered by light, if you'd like. And with that, I would like to end with like power your buildings with light. Thank you.